NFPA 70E requires both PPE categories and arc flash energy levels to be considered when selecting PPE. Face shields, balaclavas, and arc flash hoods are considered required additional PPE in certain situations. NFPA 70E Table 130.7 C15 requires face shields to be worn when there is a potential for a face burn. This can include arc flash energies above 1.2 calories per centimeter squared or working in confined spaces where there is a risk of restricted movement. Balaclavas and arc flash hoods are typically used to provide protection against burns to the head and neck. Their use is generally recommended for arc flash energies above 10 calories per centimeter squared or in situations where there is a high risk of arc flash exposure. However, these are general guidelines, and the specific requirements may vary depending on the specific task and arc flash hazard assessment. The decision to wear required additional PPE should be based on the following factors: firstly, arc flash energy level; secondly, task being performed; thirdly, specific equipment being used; fourthly, environmental conditions; and fifthly, potential for restricted movement. Different facilities have varying practices regarding the use of required additional PPE. Some common approaches include: firstly, energy level thresholds, wearing face shields, balaclavas, and arc flash hoods for arc flash energies above certain thresholds such as 10 calories per centimeter squared or higher. Secondly, task-based requirements, mandating the use of required additional PPE for specific tasks such as high voltage maintenance or working in confined spaces. Thirdly, universal usage, requiring all employees to wear face shields, balaclavas, and arc flash hoods for any task involving potential arc flash exposure. It is recommended to develop a facility-specific policy that establishes clear guidelines for the use of required additional PPE based on these factors. It is critical to remember that electrical safety is paramount, and adhering to NFPA 70E guidelines is essential for protecting workers from arc flash hazards. A comprehensive arc flash risk assessment is the foundation for selecting the appropriate PPE and implementing safe work practices. This assessment should consider all potential sources of arc flash energy, the tasks being performed, and the equipment being used. The arc flash energy level, measured in calories per centimeter squared, is a crucial factor in determining the required level of protection. Higher energy levels necessitate more robust PPE. Face shields provide protection to the face and eyes from arc flash burns and projectiles. They are typically made of polycarbonate or other impact-resistant materials and are available in various levels of protection, indicated by their arc rating. When selecting a face shield, ensure it is appropriate for the anticipated arc flash energy level. Balaclavas and arc flash hoods offer comprehensive protection to the head and neck, which are particularly vulnerable to burns. These garments are typically made of flame-resistant materials and are designed to cover the entire head and neck area, leaving only the eyes exposed. Arc flash hoods often incorporate a face shield for added protection. The choice between a balaclava and an arc flash hood depends on the specific task and the level of protection required. For higher energy levels, an arc flash hood is generally recommended. In addition to energy level, the task being performed is a significant factor in determining the appropriate PPE. Certain tasks, such as working on energized equipment or performing switching operations, inherently carry a higher risk of arc flash exposure. For these tasks, the use of face shields, balaclavas, and arc flash hoods should be mandatory, regardless of the specific energy level. The specific equipment being used can also influence the PPE selection. Equipment with a higher potential for arc flash generation may require additional protective measures. For example, working on older, less maintained equipment may necessitate a higher level of PPE than working on newer, well-maintained equipment. Environmental conditions, such as temperature and humidity, can also affect the selection of PPE. In hot environments, it is essential to choose PPE that is breathable and comfortable to wear to prevent heat stress. In humid environments, it is important to select PPE that is moisture-wicking to prevent discomfort and reduce visibility. The potential for restricted movement is another important consideration. In confined spaces or situations where mobility is limited, it is essential to choose PPE that allows for a full range of motion. Bulky or restrictive PPE can increase the risk of accidents and injuries. Facilities should develop and implement comprehensive arc flash safety programs that include regular training, hazard assessments, and PPE selection guidelines. Training should cover the identification of arc flash hazards, the proper use of PPE, and safe work practices. Hazard assessments should be conducted regularly to identify potential arc flash sources and to determine the appropriate level of protection. PPE selection guidelines should be based on the results of the hazard assessments and should be consistent with NFPA 70E requirements. Regular inspections of PPE are essential to ensure that it is in good condition and provides adequate protection. Damaged or worn PPE should be replaced immediately. Furthermore, it is crucial to foster a safety culture within the facility where employees are encouraged to report potential hazards and to follow safe work practices. A strong safety culture can significantly reduce the risk of arc flash incidents and protect workers from injury. The selection of arc-rated clothing is also an integral part of PPE. Arc-rated clothing is designed to resist ignition and to protect the wearer from burns in the event of an arc flash. The arc rating of clothing is measured in calories per centimeter squared and indicates the amount of energy the clothing can withstand before causing a second-degree burn. When selecting arc-rated clothing, it is important to choose garments with an arc rating that is appropriate for the anticipated arc flash energy level. Layering arc-rated clothing can increase the level of protection. For example, wearing an arc-rated shirt and pants under an arc-rated coverall can provide significantly greater protection than wearing a single layer of arc-rated clothing. However, it is important to ensure that the layers are properly coordinated and that they do not restrict movement or create a hazard. Gloves are another essential component of PPE for electrical work. Electrical gloves are designed to protect the hands from electrical shock and burns. They are typically made of rubber or other insulating materials and are available in various voltage ratings. When selecting electrical gloves, it is important to choose gloves with a voltage rating that is appropriate for the voltage of the equipment being worked on. Leather protectors should be worn over electrical gloves to protect them from damage. Proper care and maintenance of electrical gloves are essential to ensure their continued effectiveness. Gloves should be inspected regularly for damage and should be replaced if any damage is found. Grounding practices play a vital role in mitigating arc flash hazards. Grounding ensures that electrical faults are quickly cleared, reducing the duration and intensity of arc flashes. Properly grounded systems provide a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and energize the circuit. Regular inspections and maintenance of grounding systems are essential to ensure their effectiveness. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical systems from overloads and short circuits. These devices interrupt the flow of current when a fault occurs, limiting the amount of energy released in an arc flash. Selecting the appropriate overcurrent protection devices for a given application is crucial for arc flash protection. Time current code should be carefully reviewed to ensure that the devices will trip quickly enough to prevent excessive arc flash energy. Coordination studies are essential to ensure that overcurrent protection devices are properly coordinated and that the device closest to the fault will trip first. This minimizes the extent of the outage and reduces the potential for arc flash damage. Regular testing and maintenance of overcurrent protection devices are essential to ensure their continued reliability. Remote racking systems allow operators to rack circuit breakers in and out of enclosures from a safe distance, minimizing the risk of arc flash exposure. These systems use remote controls and robotic devices to perform the racking operation, eliminating the need for personnel to be in close proximity to the equipment. Infrared thermography is a non-destructive testing technique that can be used to identify hotspots in electrical equipment. Hotspots are often indicative of loose connections, overloaded circuits, or other potential problems that can lead to arc flashes. Regular infrared thermography surveys can help to identify and correct these problems before they cause a major incident. Ultrasonic testing is another non-destructive testing technique that can be used to detect partial discharges in electrical equipment. Partial discharges are small electrical sparks that can occur in insulation systems. These sparks can eventually lead to insulation failure and arc flashes. Regular ultrasonic testing can help to identify and correct partial discharge problems before they cause a major incident. Arc flash relays are specialized protective relays that are designed to detect and mitigate arc flashes. These relays use sensors to detect the light and pressure waves generated by an arc flash and to quickly trip the circuit breaker, limiting the duration and intensity of the arc flash. Arc flash studies are comprehensive engineering analyses that are performed to determine the potential arc flash hazards in an electrical system. These studies involve calculating the arc flash energy levels at various points in the system and determining the required PPE and safe work practices. Arc flash studies should be performed by qualified engineers and should be updated regularly to reflect changes in the electrical system. Electrical safety audits are systematic reviews of a facility's electrical safety practices and procedures. These audits are designed to identify potential hazards and to recommend improvements. Electrical safety audits should be conducted by qualified professionals and should be performed regularly to ensure that the facility is maintaining a high level of electrical safety. Lockout-tagout procedures are essential for preventing accidental energization of equipment during maintenance and repair. These procedures involve isolating the equipment from all sources of energy and placing locks and tags on the energy-isolating devices to prevent them from being re-energized. Proper training in lockout-tagout procedures is essential for all employees who work on new electrical equipment. Safe work permits are written authorizations that are required before any work is performed on new electrical equipment. These permits specify the hazards involved, the precautions to be taken, and the required PPE. Safe work permits should be reviewed and approved by qualified personnel before any work is started. Job safety analyses are systematic reviews of the steps involved in a particular job or task. These analyses are designed to identify potential hazards and to develop safe work procedures. Job safety analyses should be performed for all tasks that involve potential electrical hazards. Pre-job briefings are short meetings that are held before the start of any electrical work. These briefings are used to review the hazard involved, the precautions to be taken, and the required PPE. Pre-job briefings should be conducted by qualified personnel and should involve all employees who will be involved in the work. Continuous monitoring of electrical equipment can help to detect potential problems before they lead to arc flashes. This monitoring can involve the use of sensors to measure voltage, current, temperature, and other parameters. The data from these sensors can be analyzed to identify trends and anomalies that may indicate a potential problem. Implementing a robust arc flash safety program requires a commitment from all levels of the organization, from senior management to frontline workers. Senior management must provide the resources and support necessary to implement and maintain the program. Frontline workers must be trained and empowered to follow safe work practices and to report potential hazards. A successful arc flash safety program is a collaborative effort that involves everyone in the organization. Furthermore, emergency response plans should be in place to address arc flash incidents. These plans should include procedures for rescuing injured workers, providing first aid, and containing the incident. Regular drills and training exercises should be conducted to ensure that employees are familiar with the emergency response plans. Finally, it is important to stay up to date on the latest arc flash safety standards and best practices. NFPA 70E is updated every 3 years, and it is essential to review the latest edition to ensure that your arc flash safety program is compliant. There are also many other resources available, such as industry publications, training courses, and consulting services. By staying informed and continuously improving your arc flash safety program, you can help to protect your workers from the hazards of arc flashes.